Assalamualaikum. We from Group 10, Section 1, will present about our group assignment, which off-grid photovoltaic system design for subject BEV30303, Power Generation, Transmission and Distribution. I will introduce my group member, Aliah Afiqah binti Abdul Talib, Haniza Syahirah binti Arman, Muhammad Aliff Nadzmi bin Ahmad Kamal, M.Rifqi Aiman bin Azizan, and me myself Nadzirah Syazwani binti Muhammad Fauzi.
Hi, Assalamualaikum. My name is Haniza Syahirah binti Arman. My matric number is DE200109. For this project, I'm going to talk about the abstract. So, for nowadays, we know that people are more interested with the sustainable energy technology, which is can give more advantage or more benefit for the consumer or the user, even though the costing to install the sustainable energy technology is pricey, but the consumer can reducing the costing of electricity, beside can keeping the environment clean and green. So for this project, we are using the photovoltaic panels, which is generate the power electricity by using the solar cell to convert energy from the sun into the flow of electrons by the photovoltaic effect. So as we know, the solar cell are producing the direct current electricity from the sunlight, which can be used to power equipment and used to recharge a battery. Other than that, when switching the solar power, there are two types of the switching the solar power, which is first is the grid type, and the second one is off-grid solar system. But people are usually use the off-grid one because it's an independent system, which is an alternative option to generate the electricity to provide the power to their home. So for this project, we using the off-grid photovoltaic to install it to Mr. Ahmad Nisfu's house, to provide the electricity that needed to his house. So the next one is to explain the complete documentation of an off-grid photovoltaic system via manual approach and by using the software. So I will pass it to my other members. That's all from me. Thank you.
Okay, I will explain about introduction. A photovoltaic or solar cell is a type of renewable technologies that converts sunlight directly into direct current DC electricity. An off-grid photovoltaic generator system electricity to be produced by solar panel and stored in a battery without being directly connected to the utility grid, providing an independent power supply for our home. It is possible to run a home with solar energy even at night or during times where there is less sun exposure by storing the electricity in a solar battery. The purpose of the photovoltaic system is to help reduce the usage of non-renewable energy. Okay. Here is the connection from for off-grid panel solar, which the sunlight directly through the panel solar and energize the DC charger, store the energy in the battery bank. They have AC inverter, backup generator, and connected to our house. Okay. Problem statement. The world demand for electric energy is keep increasing, and non-renewable energy resources are threatened to be depleted. Plus, the prices are also rising by years. For some reason, the needs of alternating energy sources become higher, and solar energy is one of the alternating energy that can be obtained easily and pollution-free nature. Solar panel produce electricity by exploiting the heat contained in the sun radiation. Before installing solar solar cell, we should take note that not all solar energy reach the surface of the Earth. Hence, only around 46% of energy, 700 million terawatt per hour, actually reach the Earth surface. As we know, solar energy is free, but the initial cost for installing photovoltaic system is high, since cost of the component are expensive, such as photovoltaic array and battery block. It is important to determine the accurate size of photovoltaic system to achieve the load needs. The objective for this assignment is first to design and build a suitable off-grid photovoltaic system for achieving so via manual approach and using PVC software for residential houses. To provide the benefit by installing photovoltaic or solar cells to minimize daily electricity consumption. And lastly, the use of renewable energy can reduce the usage of non-renewable energy like food.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aliff Nadzmi by Ahmad Kamal, BE30303-POWER. I will continue by presenting the designing of the photovoltaic system. Okay, firstly we have electrical load analysis. So we need to determine how much electrical energy is necessary for the home to run any electrical appliances. So we have used this formula of total power consumed is equal to the quantity of load multiplied with power of load and multiplied with hour. So the final answer for the daily power consumed for a single story house that we have chosen is 15.142 kilowatt hour per day. So for the energy consumption for 1 month and 1 year is 15.142 kilowatt hour per day is multiplied with 30, and we have 454.26 kilowatt hour per month. And for energy consumption in 1 year, we can obtain by 454.26 kilowatt hour multiplied with 12, and we will have 5451.1 kilowatt hour. Okay, for the sizing of grid photovoltaic system, there are some of components that we need to take care of by calculate the suitable size and the number of the component. Okay, for the first component is a solar PV panel. So by having the information of the total power consumed 15.142 kilowatt hour and the sun peak hours in Malaysia is 5 hours, so we will calculate the PV power system, which is a solar panel that required is 3936.9 watt, and the number of PV panel is 10 PV panel required, and the number of module in series is 6, and the number of strings is 2. So number 2 is the sizing of battery bank. So there are some of battery specification that we need to know, which is a type of battery we use, depth of discharge, efficiency, and also the battery rating. So for the battery bank capacity, we obtain the value of 664.1 ampere hour, and the number of battery that connected in series is 6, and the number of battery that connected or we can say the branch is 4. So next, for number 3 is the sizing of the inverter. So we have a load, the power per unit of the load, quantity, and also the multiplier. So the multiplier, we put 2 or 3 for the load that containing a motor, and 1.3 value for the other appliances, and we multiply the power per unit quantity and multiply with the multiplier, we will obtain the total value. And for the minimum inverter power is 11.596 kilowatt. So for the sizing of solar charge controller, so by using this formula, we multiply the short circuit current in module, module in parallel, and multiply with 1.3, we will obtain the 28.86 ampere. So the last is a total cost of installing an off-grid photovoltaic system. So there is equipment for the PV module, battery, AC controller, inverter, and the quantity, also the price per unit, and we obtain the total cost is 28,187.75, and the maintenance cost for a year is 295.20 cent, and the total cost that we obtain by multiplying the estimate cost of equipment and maintenance in a year, we have obtained the RM 28,482 and 95 cent. So that's all from me for the documentation of the design.
My name is M.Rifqi bin Azizan. My meeting number is BE30303-POWER. Alright, for my part, I will show you how to make a simulation by using a PV system project software. So first, when you open it, we need to click new, and then we need to mention the project name, and then at the site file, this part is to put the longitude and latitude, which is the specific of your location located. Alright, okay, the latitude and longitude, also altitude, you can get it from the Google Map, where is the place of the house, and then get the latitude and longitude from that, also the latitude. And then for the time zone, we use 8 because our site is at our country, which is Malaysia, and the region is in Asia. After that, for meteo data import, we use meteonom 8.0. So the import data is to show the weather condition in a year about our place. After that, just click OK. Alright, after that, this is also the important part. Alright, first we need to what we call put the main parameters orientation. Alright, for this we use a tilt 30 degree, which is the PV panel tilt is 30 degree, and then you need to select the yearly irradiation yield, which is it consists of weather in summer and also in winter. Then just click OK. And then user need, this is also the important thing, all of this daily consumption that you need in the house. Alright, for Mr. Nisfu house, we just assume or estimate it use LED lamp 8 unit, TV 1 unit, and domestic appliance it consists of 3 things, which is microwave, jug kettle electric, and also rice cooker. And then this is freezer or refrigerator. Dish and clothes washer is actually a washing machine, and air conditioning, and also ceiling fan. Alright, from this you can adjust the hourly distribution in a day at every type of appliance. After that you finish, you can click OK. OK again. And then for the system, alright, at this part you will choose your battery capacity, how much you want, and for our group we use a generic type, which is the battery is a lithium ion, and the voltage is 48.1 volt and 120 amp per hour. Alright, this is our battery spec, and then this is PV array, which is our PV panel type. We use a generic model, and the power is 400 watt with 32 volt, which is this is a silicon monocrystal PV module. And then our solar charge controller, we use MPPT converter. And then this is the series and string number for our PV module. So the calculation to get the series and string is already in the main calculation. Alright, after that finish, you can click OK. And then alright, after that you ready for simulation, just click run simulation. After you run it, okay, this is the simulation report, so which is same like simulation result. So this simulation result, it consists of all of that you set by using simulation. So this is project summary, this is the latitude and longitude of the location of Mr. Nisfu house. And then in system summary also, it already mentioned how many PV array that we use, which is 12 unit, and the battery pack is 24 unit of battery that we use for Mr. Nisfu house. And then this is the parameter that mention the orientation of the PV module and the PV array characteristic. You can see it. Alright, it consists of battery and PV module specification, also the controller. And then for the cost of the system, we just estimate the total cost of the system, and you can put the real value, the cost in this section, economic evaluation. Alright, it already calculate for you the quantity of component that you use, and you just get a unit price from your internet or from your research. And then this is all the maintenance that we get. That is an estimate from us or assumption. And then just click OK after you already set it. Alright, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afiqah Binti Abdul Talib. My matrix number DE200082, and I will continue the presentation for discussion and for summary. Okay, so first is discussion. Types of battery that will be used in the system is lithium-ion battery, because it is a highly developed battery technology that relies heavily on lithium-ion as a prominent component of its electrochemistry. Next is lithium-ion battery have the potential to contain a very high voltage and charge storage per unit mass and unit volume. This demonstrated that lithium-ion batteries can supply large amounts of current for high power applications while requiring relatively little maintenance for the battery. Next is types of solar charge controller or SCC. So types of SCC that will be used in the system is MPPT or maximum power point tracker. MPPT is an advanced controller that capable enough to empower the solar panel to behave at its maximum power point. The working principle of the MPPT is very simple. First, we know that the varying of sunlight radiance that encounter on the solar panel causes the panel voltage and current to change continuously. So MPPT will track through the panel voltage to find the best point that have good combination of voltage and current that able to produce the maximum power. Okay, next is the comparison between manual method with PV system software. So the first parameters is total power consumed. If we calculate manually, we get 15.142 kilowatt hour. If we run in the simulation, we get 15.2 kilowatt hour per day. The value is slightly different because in the simulation it includes extra load, so that's why the value is slightly bigger than manually. Next is PV power system. So if we calculate manually, we get 3936.9 watt, and if we run in the simulation, we get 4800 watt. For the number of PV panel, by doing manually, we get 10 units, and if we run in the simulation, we get 12 units. For number of module in series, both method we have same value, which is 6 modules, and number of string also same, which is 2 strings. And for number of module in series and number of modules in parallel for the battery, both method also get same value, which is for series we get 6 modules, and for parallel we get 4 modules. The total cost of the system, if we calculate manually, we get 28,187.75 ringgit Malaysia, and if we run in the simulation, we get 34,972.75 ringgit Malaysia, because in the simulation it include with the building insurance, so that's why the total cost of the system is quite large compared to the manual calculation. So for the total maintenance cost, by doing calculation manually, we get the value is 295.20 ringgit Malaysia, and for the PV system software we get 4,335 ringgit Malaysia. Okay, last but not least, I will proceed with the summary. PV system software is a very limited software that can provide technical design, sizing, data analysis, risk mitigation, potential losses, and return on investment aspects of a solar PV power system. In comparison to the manual method, manual calculation method might not be as accurate as PV system software because there is possibility of a miscalculation occurring during the manual calculation. There are 3 types of PV system that can be designed in the software, which are grid connected system, stand-alone system, and pumping system. The method that we use for Mr. Nisfu's house is stand-alone method, because in stand-alone method we required a battery or any storage device that can store for the energy. So through this project, we're able to identify the difference between manual method and also by doing simulation. So that's all from our group. Thank you.